Hello everybody, I am back for another calculus video, and from now on I'm going to try to explain things a little bit faster to make the video less draggy. And so I just want to read this problem. Let f of x equal f prime of x over g of x, where g of x is a quadratic function. If f of 0 equals 1, f of x is greater than 0 for all x, the vertex for g of x is at 0, 5, and the integral from 0 to 5 of g of x dx is equal to 150. What is f of x? So, for those of you who are in Calculus 2, this shouldn't be a problem. And for those of you who are Calculus 1, this might actually be a challenge. So, please give this a try, and when you're ready, keep watching the video. Alright, so first thing we should do is find out what g of x is. So we're given that g of x is a quadratic function. So we know that, well, let's just write it in the standard form. So g of x is equal to ax squared plus bx plus c. And so we are given quite a few information here. So we know g of x is at 0, 5, the vertex. So we know straight away that the c value is 5. And we also know, since the vertex is since the axis of symmetry is at 0, that means that b is equal to 0. Because if the b value is different, then it would actually move a little bit horizontally. But since it doesn't move horizontally at all, it only moves vertically, there is no b value. And so we now know it's just going to be ax squared plus 5 for g of x, but we still don't know what a is. That's why this integral right here exists. So we know the integral from 0 to 5 of g of x is equal to 150. Let's try to actually plot this down and see what happens. So the integral from 0 to 5 of g of x, which is ax squared, no, I shouldn't write my a's like that, ax squared plus c, which we already know is 5. And so when we evaluate this integral, we will get ax cubed over 3 plus 5x evaluated between 0 and 5. And so we have to plug in the top limit of integration and then subtract and plug in the bottom limit of integration. So the bottom limit is 0, and both of these are x terms, so the 0 will just be 0 when you plug it in. So let's just worry about the 5. So 5 cubed is 125, so it's going to be 125a over 3 plus 5x, 5 times 5, which is 25. And again, yeah, that's what we got from this integral. And remember, this is equal to 150. And so we can set this equal to 150, and we now have an equation that we could solve for a for. So first thing we could do is subtract 25 on both sides. So we will get that, we will get that 125a over 3 is equal to 125. And so then we could divide by 125, well, let's just multiply by 3 over 125 on both sides, so that all four of these cancel out. And we have to do it on this side too. And these two will cancel out. We will be left with a being equal to 3. So we have that now. Let me also underline these so we know the values we found. And so now we have g of x completely evaluated. We know g of x now is equal to 3x squared plus 0x plus c, which is 5. And so now we have g of x, which is definitely a step forward. Now we have to move on to this equation right here. We have to let f of x equal f prime of x over g of x. And so I'm going to write these without the of x's. So this will just be, well, f of x we could rewrite as y, and is equal to, actually I'm going to change the color because this is a different, technically, section or part of the problem. I'll let this be light blue. So y will now equal f prime of x or dy dx, and then over, let me make this a little bit nicer, dy dx over g of x, which we know is 3x squared plus 5. And so here we just have a differential equation. We have a function, its derivative, and another function of x. And so what we'll do now is we will multiply both sides by 3x squared plus 5 let's see the entire equation by it. And then we will also divide both sides by y while we're at it. And so then we will be left with, on the left side, we'll just have 3x squared plus 5. And on the right side we'll have 1 over y. Oh yeah, let me also move the dx to that side multiplied by that. So dx, and then is equal to 1 over y dy. And so now I'm sure you know what to do. We will now integrate both sides, and we will end up getting the integral of 3x squared is x cubed, and the integral of 5 is 5x. And then we will have our constant of integration. And then on this side, the integral of 1 over y dy is just the natural log of the absolute value of y. But we're given up here that f of x is always greater than 0, which means that we don't need the absolute value. We know that it will always be positive. So we can just have the natural log of y here. And so we are getting close to finishing this problem. We will now raise e to the power, we will now raise both sides to a power of e. And so on the left side we will just have e to the x cubed plus 5x plus c. And on the right side we will have e to the ln, or just y. And so now we have one more information that we need. We know that f of 0 is equal to 1. So now we could find the value of c. We know f of 0 equals 1, which means that we will get e to the 0 cubed plus 5 times 0, which will just be 0. Or in other words, just e to the c is equal to y, because y, it'll equal 1. Because that's what f of 0 is. That's what we set it equal to be. So now we will just get, when we take the natural log of both sides, we will get that c is equal to ln of 1 or 0. And so c just doesn't matter here. And so finally, we know that y, or f of x, is equal to e to the x cubed plus 5x power. And we are done. That was the answer to the question. And I hope you guys enjoyed this video. This problem was actually pretty challenging to make for me because I'm not used to making problems like this. Yeah, I enjoyed making it, and I equally enjoyed solving it. Anyways, if you'd like to see more videos, just tell me what you'd like to see in the comments, and I will see you in the next one. Take care.